Okay, so welcome again. So now let's first understand the structure of the node. We are going to do the coding now. So simply I'm going to create one class and I will give the name to this node. Okay. And as I told you, node is having two data. One is data itself, second is the reference or next of that node, right? So int data and node, I'm going to use the same class as is reference it to the same structure, right? So next, this one, and I'm going to create one constructor which is going to take your data and it will initialize this. Okay, int data, sorry. Okay, and in this I'm going to simply this dot data equal to whatever data I'm passing, and this dot next, that is equal to null for the new node, right? So this is the structure, and it's a very basic structure, right? So now we are going to do operation of insert. So insert, what happens? There are multiple cases. Okay, so let me first explain what is going to happen when we're going to insert at the beginning. So we are going to talk about the first beginning case. Okay, suppose we are having some nodes. Okay, let me create some sample data. Okay, let's say 10, 20, 30, 40, and I am asked to insert one node at this position at start, right? So suppose I'm going to insert one node with the 5 value and I have to insert here. So I know that the next of this is nothing but null, correct? And start is always pointing by the head, right? This is clear. Okay, so we know that whenever you are going to read any linked list, you are going to start from the head only, right? There is no other way. So first I'm going to create this node object is created. What I have to do, this node I have to insert here. So what I have to do, first the next of this node must be the previous head node, right? So head earlier pointing to this, since it is coming at the first place now, so head should point to this only. It means the next of this new node should be head. All right, now so I have put the next of this node to the head, and the head is pointing to this. So ultimately this is going to be connected now, and since head is still there, now I have to change the reference of head. Now head should point here, right? So I'm doing all the operations here, only this place, right? And since this is some mathematical operations, it's a fixed part, so it's going to take order of 1 complexity. Perfect. Let me check one more case, then we'll do the program together. All right, so now I'm going to talk about insert at end. Okay, so what happens at the insert of end? So it says whatever linked list we're having, insert the data in the last, right? 10, 20, 30, 40, and one new node is given, suppose 50. So your head is here. You cannot reach directly to the end of this list, end of this linked list. It's not possible. It means because your starting point is always head. So first you have to reach here. And how to identify this is last node? The next of this node is always null. Remember this, right? So let's going to do the traversal. So I'll start from here, then I'll come here, then I'll come here, then I'll come here. Once I come here, then when I'm going to move from here, that node is coming null. It means I am at the, right now I am at the last node. Once you reach the last node, just stay there. What I do, simply I have to bring this node here, and this node is already next is null for this, you know that. simply the next of this 40, a last node has to be point this. Simple. It's okay. Okay. Now coming to another case, insert at given index. What does it mean? It says that you are having multiple nodes. Okay. And let me give 10, 20, 30, 40, 50. Someone is saying there is one node called 35. Insert this as position number 3. So 0, 1, 2, 3, 4. It means you have to insert after 2 here, right? So this is right now connecting to this. I'm going to insert here 35. It's not that much easy like previous two cases. So what I'm going to do, I'm little bit stopping from here. Okay, I'm giving you some time. Just think like how this it should work. Then we'll do this program again. So in that time and meanwhile I'm going to implement these two cases. Okay, so just think about this. I will do later. All right. Okay. All right. So before that, what I want, node is created, but we don't know actually the basic thing, how to interlink this node. Let's do quickly. Then I will do the insert in beginning and insert in end, right? So let's do that. Okay. So for this, let me create one more class, one main class where I will give all this demo. Okay. So I'll create one class called LinkedList demo, right? Okay. In this now, I'm going to create one main method and I'm going to create multiple nodes because node structure is already ready. So node n1 that is equal to new node. Okay, and I'm going to pass some number 10. So this is one node is created. Let me create 3 to 4 nodes. Okay, let me rename this 2, 3, 4, right? And give me that. Let me change the number also. Okay, so this node are individually created. They don't know about the n1 is not knowing the n2, n3, n4. They don't know what is the next of me. Next is null for them because they are single node linked list kind of. So now let's do linking. So what I'm saying, suppose I want to make a relation like n1 is pointing to n2. N1 is having the reference of n2, n2 is having the reference of n3, and n3 is having the reference of n4. So let's do that. What I'm going to do, n1 is having the reference of n2, and n2 is having the reference of n3, and n3 is having the reference of n4. Okay, so what I'm going to do here, n1 dot next is what? N2, correct? N2 dot next, what should be? N3, right? N3 dot next, this should be N4, right? N4 dot next, if not giving, by default it is null, right? Because it's a constructor is setting those things. Now if I'm going to print all this data, it will come in that order only. I will simply start with head. So let me create one node head. My head is pointing to n1. Okay, so remember one baseline in linked list. Whenever doing any kind of program, never touch head pointer directly. Never do any operation, any movement on the head, because once head is going to left its position while processing, you will never come back to the start again, because there is no memory for that, keeping all the track of recording from where the head is started. No, right? So whenever doing any operation, just create another reference of the head. So I'll say node current, because I'm going to process on the current node only, and this is pointing to the head. So whatever the current value you are setting, this is not going to be disturbed. So whenever you want to find out the start node, this is always pointing to the n1. So for that reason I am saying that. Okay, so since it's a kind of arrays of data, I'm going to simply add a while loop, and I will keep traversing those data until I reaching the last node. Last node means a node which is having next as null. Okay, so while current is not equal to null, I'll keep moving until that. So I'm going to simply system dot out dot println, and I'm going to print current dot data. Fine. And since once I got this data, I visited this node, then I'm going to move the current to the next one line. So my current will become current dot next, right? So let's do this. So this should print in how? First 10, then 20, then 30, then 40, right? Because we have made that connection in that way. See. So hope this makes sense, right? Okay. Now we are going. It's a basic things. I mean, how to make interlink the node, how to traverse this, a simple method. Now we're going to do our main operation, that is insert at beginning, right? So let me create another class, insert at beginning. Spelling is okay, right? I think double N is there, should be beginning. Okay, otherwise it will show some compilation issue. I mean some highlight, it will give some mark. Okay, so we already have the node structure, so I'm simply going to create node head. First thing, I'm going to initialize this variable. Okay, I'm going to write one method, public. It's not going to return anything, void insert at beginning, correct? And I'm going to pass simply int data in data. Okay, so the first thing is that first create the node structure of this given data. So node, new node, that is equal to new node, and I'm going to pass this data. Okay, so new node is ready. So if you remember the discussion, what we're doing, we are going to set the next of the new node is head, because head is pointing the older starting point, right? Now this new node is going to be the starting point, so head should always be there, right? So currently what I'm going to do, I'm going to point out the next of this new node to the head pointer. Okay, so new node, so new node dot next should be head now. So whatever head is pointing earlier, now it is pointing to the node next, new node. And now, I mean that connection is okay, but still our head is pointing to the n1, or head is pointing to the previous starting point. That also we change, because now new node is becoming the starting point. So I'm going to put simply in the head is nothing but new node, right? So this is the simple case for this. Okay, these three lines of code inserting at the beginning. So let's write one utility method display so that we can print this. Public void display. I mean we can call the previous method also. So for that I have to actually okay, let me copy this, because this is the same thing that I'm going to do. Okay, let me write it simply, that will be much better, right? Public void display, and simply I'm going to pass nothing big. I don't have to pass anything because this object is already there. So I'm going to pass node current, that is equal to head. Okay, and now I'm going to simply put this while loop, and where I'm going to check current, the same code, current should not be null, and let's traverse until that. Okay, so current is not equal to null. I'm going to simply system.out.println, and I'm going to simply pass current dot data, and let me put some arrow also in that so that we can see the connections. Okay, and then I'm going to move the current position. Current equal to now current dot next, right? My utility method is also okay. Now I'm going to create simple main method. In main method, what I'm going to do, I'm going to simply call the object of this insert beginning list. Let me create some data first. So new insert at beginning. Okay, I am simply going to list dot insert at beginning. Let me give some data now. Let me give 30, and let's copy this now. Okay, so now just think, if when this line is going to be executed, what will happen? There will be simple one node is going to be created, that is 30, and head is going to point this 30, and next of this 30 is nothing but null. Just imagine, visualize this. There is a single node which is having next as a null, and head is pointing to this 30 node, right? When this line is going to happen, what will happen now? 21. When this 20 we are going to insert, what will happen? It is going to push 30, I mean from first position to second position, right? So now what will happen? Head is going to point to the 20 now, and 20 next is nothing but it's a 30. In the same case for this, so that's why I have taken this 30, the first insert I have 30, so that it will print 10, 20, 30 kind of, so it will be more rational, right? Okay, now simply once it is done, the list dot display method is there. It will going to print those in that order. Let me run this now. See, 10, 20, 30. Perfect. Yes. Let's remove this ln. It will print in more readable format. See. So this is how it's going to work. Since all this done, if it is null, then in the last we can print null, because this arrow is coming one extra arrow, right? So it's not looking good. So just I'm putting here null, because last always be null, right? Now let's run this. Right, it's a perfect way. Okay, so you have seen this insert at beginning. In the same way, we are going to talk about insert at end, right? So let me create one more class. I'm just getting the class separate because whenever you're going to run, all sets of that changes should be in the one class. If I'm going to change in this, what will happen actually? I'm going to comment then some code, then I'm going to write new code. So it's very mix, right? So it's not better for understanding at this point. So let me create another class, and I'm going to give the name of this class insert at end. Fine. Okay, so I'm simply, this is basic step that I have to do till here. Okay, now insert at end. So if you remember what we're doing, the visualize this, the linked list structure, or we can start only from head. So we have to first reach to the end of this linked list. We are at a start position, so we have to traverse each and every node, and we have to traverse until we reach it to the null. When you are going to reach to null, it means you are at the last node of that particular linked list. Once you reach there, then you are going to set next up the last node is nothing but the new node. Perfect. So first we have to traverse till the node from where the next of that node is null. So in this case also, like let's say this one, so I have to reach this 30. So how do we reach? We're going to reach 30 if next of this node is null. Whatever node is we are traversing, 20, 30, 10, if next is null, just stay there, stop the loop, break the loop, right? So let me do that first. Okay, so first I'm going to create a new node because data is there, right? Before that I have to create one method, right? So let me create one method, that is public void insert at end, and this I'm going to simply pass int data. Okay, all right. In this I'm going to first create the node as a new node. This is the first step that I'm going to do in this. Data, this node is created now. Okay, what I told you, there are two cases in that also. Insert, you're going to insert in the last. There are two cases. First case, suppose initially there is no node in that whole list. It means you are going to insert in the last, which is nothing but is the first node only. So it's the same case like insert at the start. So if your list is empty, then you have to create a new node. It's just like starting at the start of the linked list. And second case, if at least one node is present. So first we are going to solve if list is empty, means linked list is empty in that case. So in this case, how do you check if list is empty? Head is must be pointed to the null because there is no node. So if head is equal to null, means there is no list in the linked list. Then what you do is we are going to simply pointing the head to the new node, right? I simply return it because you have inserted this in the last and first both are same in this case. Otherwise, if it is not null, then we are going to do this traversal. So note, I told you always whatever operation you want to do on the current node, not on the head directly. Okay, so I have put that now, and I'm going to simply write one while loop while your current dot next is not equal to null. You have to traverse till that point. Whenever next become null, it means your current is pointing to the last node simply. Okay, so if this is true, then current equal to current dot next. Simply keep moving on, right? Once this loop is broken, you are at the last node of the old linked list. So what I will do, current is the last node. You have to simply set the new node to the next of the current node, next of the current node. So current dot next is nothing but new node. Anything that you didn't understand? This is the one case. It's a special case when your list is already empty and you are going to insert the first node at the end. It's same as first node at the beginning, right? And after that, this rest case I already discussed on the whiteboard as well. Okay, now I'm going to simply write one display method. So for that I'm going to copy this now because I'm not going to write this again, and simply I'm going to paste here. And once this is done, then I'm going to create a main method. So in main method I'm going to create the object to insert at end. Yes, let me create one data. So insert at end, right? And list dot insert at end, I'm going to say number 10. Let me copy this now 3-4 times. Okay, 10 is done, 20, 30 40, right? And simply I'm going to call list dot display. So how this data going to be printed? Every node at the end, the first 10 will be printed, then 20 will be printed, then 30 will be printed. So I'm doing, this is this case when I'm going to insert. Suppose if I comment this out, then what will happen? It's the same case for this one, because initial list is empty and we're inserting just one node, right? So all the cases will be solved in this, right? So let me run this now. See, 10 20 30 40 and last is null. Okay, so we are done this now we are going to talk about the problem that I have given, insert at a given position, right? So let's talk about now. So first for that, first let me display like how the things are going to work in this case, then we'll write the program for that. To insert at a given index हम बात कर रहे थे, so we are talking about this, right? Okay, so suppose this is given and you were asked to insert a node at suppose third position, right? So what are you going to do? So first my head is here, I have to traverse till this point. And how do you identify that you are here? Whatever index I am saying, you have to reach before this. So third index 0 1 2 3, so you have to reach just previous to the given index, right? Once you reach here, then what I have to do now, let me take this portion only, 30 40, and my new node is there 35. So this is my current position, right? This is my new node. So what I have to do, I have to just change the interlinking, but it's a very ordered way. Let me take the correct way first. So next of this new node should be this. So it means the next of this new node is nothing but is current dot next. So what I have to set here, new node dot next should be current position dot next. So my this pointer is pointing this and this is also pointing to this. So I have to break this, right? Because this is already pointing. Now what I have to do, current dot next. Now I have to set the current dot next, that is nothing but the new node. So current dot next is now pointing to this. So just remove this and you got your linking. Fine. Hope it makes sense, right? Now let me reverse this statement. Let's see what is happening. Let me write it here again. 30 40 and 35 was there. This is already connected. Let me do this first. So what I'm going to do, current dot next should be the new node. That is also correct. So I'm breaking this now and I'm doing this. Okay, this is already there. Now I'm going to run this. So new node dot next is nothing but current dot next. If you see current dot next, there are two cases. This is also next, this is also next, which is not a case, is invalid case, right? So if I'm going to do this step, then I have to stop this. Once you remove this linking, after this everything is lost. Now after that you will never find this. So that's why this order matters. Okay, so remember this. You have to do this in this same order. Fine. Okay, now let's write the code. So this is the only case that you have to understand in this, right? So let's write the code now. So I'm going to again create one class insert at position, right? So insert at position demo. So for this, simply I'm going to do the same thing. First node equal node head, I'm going to initialize, right? After that, what I'm going to do, I'm going to create one method, and I'm not going to return anything in this case also. So public void insert at index, right? Or insert at position. So now there is one difference in this input parameter. Now in this, we are going to take two parameters. One is the data that I'm going to take into data, and second the position. Okay, on which position this has to be inserted, right? Okay, so let me create the new node now. So node new node, that's equal to new node, and I'm going to pass the data in this. All right. Okay, now in this one small case that I have to understand, if your position is 1, what does it mean? If position is 1, it means you are going to insert the data at the first place only, right? As a start, as a beginning. So this use case we are going to solve separately. So if my position that is equal to 1, then simply I'm going to write the logic of the insert at start. So new node dot next, I'm going to pass the head, and head will now point to the new node, right? And simply return from here. Understood? Okay. Now in the rest of the cases, we have to think the logic that we have discussed, right? Okay, so since I told you whenever you are going to do any operation, just create the current, which is a reference of head only. Okay, so in this, I'm going to start the for loop because I have to reach that particular given index. So for int I that is equal to 0, not 0, it is going to start from 1, right? And I should be less than the given position minus 1, right? And I think it's okay. Okay, and simply I plus plus, right? So I'll move my current equal to current dot next. Okay, so once I reach the before the position, I am at the just previous node of that required position, right? And I have to check, it may be the it may be the last one, right? So I have to check if your current equals to null, then simply have to return it, right? So this is the case where whatever position you are asking, it's more than the length of the given list, right? In that case, this will going to help. Now what I have to do, simply what I have to do, as I told you, we have to set the next of the new node to the current dot next. Okay, so new node dot next, that is equal to current dot next. Still the current is pointing to the next, and the new node also pointing to the current next. So you have to break that, right? So now current dot next, that should be your new node. Fine. So this is the whole code. Okay, it's a little bit trickier than the previous two cases. Okay, so now let me copy the display method here from this. Right here. After that, I'm going to create one main class. In main class, I'm going to simply create insert at position demo, and I'm going to do the list equal to new insert at position demo, and list dot insert at position. Suppose I'm giving first let me create the the one structure should be there, then I'm going to insert one node at given position. So let me prepare one linked list first. So insert at end. So for that I can write, so I'm adding this position now, this method here, and simply going to call in this. Okay, so our insert at position. Okay, so I'm creating the list and I'm going to insert this, insert at first at end. Okay, so let me just do this. So I'm not required this because this method is already there, right? Both method in this. Okay, or insert and position. So let's run that, and let me add here one, so just to system.out which was the previous one and which was the last one. So let me write before. Okay, and this should be after. Let's run that now. So before this was there. Okay, let me do this. Okay, we have to, let me do one break here. Okay, simply, so just for the visibility purpose I'm doing that. Okay, so before 40 50 40 20 10, right? 30 I want to insert at third position. So now see after that what happened after 50 40 30 10. So this is the correct one, right? So in this way we are able to do this operation. These three are the major operations. So now after that we are going to talk about some use cases for this, and we'll implement those in the next video. Okay.